Welcome back. This is our last pre-calc review lesson before we really get to dive into the calculus stuff. And I think I've mentioned this pretty much in every lesson we've done so far, but this one's really important. You've got to know exponential and logarithmic functions really well because we use them all the time. So today we're going to answer the following questions. How are exponential and logarithmic functions related? What are the important properties of exponential and logarithmic functions? What are the domain and range of the functions? And finally, how can we make composite functions with these? And actually, we're also going to say, how can we solve some of these questions? So let's dive in. An exponential function involves a constant raised to a power. So the base here is just some constant number, and it's raised to some sort of a power. Now it's important to make sure you remember and can use all the properties of exponents. So pause this for just a minute, read over these, and make sure that, yes, indeed, you remember how to use exponents. So if we have some constant raised to a positive power, it's an increasing function, whoop, like this, way up into infinity. And if it's raised to a negative power, it's coming down really fast. But notice it never crosses the x-axis. So the domain of each of these functions is negative infinity to infinity. There's no restrictions on x. The range is 0 to infinity. So see, it's always positive. It's always just above. These are both above the x-axis. And the y-intercepts for both are 0 and 1. Now just a note, if you wanted something to go below the x-axis, a negative constant in the front would reflect these down off of the x-axis. So you'd have, there you go. Those are now below the x-axis. And then what we know is the range is now 0 to negative infinity. These are all negatives. And the y-intercept is 0, negative 1 right there for both of those. So that's a quick overview of exponential functions. Now, can you picture these in your head? Y equals 2 to the x, y equals 3 to the x, y equals 5 to the x. We just covered what an exponential function looks like, right? It goes whoop, sort of like that. Now, which one of those, 2 to the x, 3 to the x, or 5 to the x, which one of those grows the fastest? If you look at this graph, you'll notice that as the constants get bigger, the graph grows faster, doesn't it? Now there's one constant that we spend a lot of time with in calculus, and that's e. And when we take e and raise it to a power, it's called the natural exponential function. It's a one-to-one function. It has an inverse. Its inverse is ln of x, or the natural log of x. And it's an inverse, it's reflected over the line y equals x. So e to the x has all the properties of an exponential function. Its domain is negative infinity to infinity. Its range is 0 to infinity, and its y-intercept is 0, 1. Its inverse, ln of x, or natural log of x, well, the domain and the range switch. So the domain of ln of x is 0 to infinity. The range, negative infinity to infinity, and now the x-intercept is 1, 0. There are some really important facts to remember that will make problem solving in calculus much faster. I'm going to show you these important facts in both exponential form and logarithmic form. So again, make sure these are seared into your mind and you can do them at any moment. E to the 0 is 1. The logarithmic form of that is that ln of 1 equals 0. E to the 1 equals e. Logarithmically, ln of e equals 1. E to the negative 1 equals 1 over e. And logarithmically, the ln of 1 over e equals -1. Certain properties of logarithms are also important. If you have ln of x times y, you can expand that into the ln of x plus the ln of y. Similarly, if you have ln of x divided by y, that can become ln of x minus ln of y. And ln of x to the z, that z in the exponent can just come forward to get you z times ln of x. To practice that a little bit with some of these problems. So ln of 10 divided by 9. So this 10 divided by 9, that division sign is going to become a subtraction. ln 10 minus ln of 9. Number 2, we've got 3x plus 2, but it's under the square root sign. So what's important is to be able to change roots into exponents. So we're going to change that to ln of 3x plus 2 to the 1/2. Now this 1/2 can come forward. Let me clean this up a little bit. Okay, ln of 6x over 5. We'll start by separating at the division sign. So ln of 6x minus ln of 5. And maybe you're done, but look at, we've got this multiplication. ln of 6 times x. So that will go ln 6 plus ln x minus ln 5. All right, you ready for a complicated one? We're going to take this division sign within the log and change this now into a subtraction or a difference problem. So we've got natural log of the top minus the natural log of the bottom. On the top, this 2 is going to come forward. And then when we're working with the bottom, there's a couple things to recognize. First, there's 2 functions there. X times the cube root of x squared plus 1. And again, just remember that the cube root of x, if we're going to write that in exponential notation, is not x to the 1/2 at all. It's x to the 1/3. And most of the time in calculus, we're using exponential notation. So be really familiar with how to get from root notation to exponential notation. So this multiplication sign right here is going to become a plus. So here's what it looks like now. It looks scary, but it's really not that bad. We're almost done. This is about as far as we can get on this left-hand side, so maybe we'll keep that. The only thing, we've got this guy, this 1/3 can come to the front. There we go. We've expanded that. Now, solving logarithmic equations is kind of cool. Because logarithmic and exponential equations are inverses of one another, we're going to use that. So we're going to figure out how to solve for x. We got to get x by itself. But you'll notice that x is in the exponent here. So how do we get it out of the exponent? We're going to take the natural log of both sides. So you get ln 7 equals ln of e to the x plus 1. So now this guy here, this x plus 1, this can come forward like that. Okay, so then you've got ln 7 equals x plus 1 times ln of e, and the ln of e is 1. So it kind of just goes away. ln 7 equals x plus 1, subtract 1 from both sides. You can leave it there, or if you really want to know the decimal form of that, 0.946 is approximately equal to x. Right, now what happens if x is stuck here inside the natural log? Well, what we do is exponentiate both sides. So each side of this equation becomes an exponent of e. That's called exponentiating both sides. And because e, see here, and the natural log are inverses of one another, what's left is just what's inside the natural log. So 2x minus 3 equals e to the 5th. And we can add 3 to both sides and divide by 2. That was a quick crash course in exponential and logarithmic expressions and equations. And with that, you guys, we're ready to start calculus. Okay, so I'll see you in Unit 1.